Good morning. Today we are going to discuss 1-3, which is multiplying probabilities. The probability of two independent events. So the key word we are going to look for probability of two events is and. Anytime we see and, we are going to multiply. So if two events A and B are independent, that means one does not affect the next event. Then the probability of both events occurring, so we want both of them to happen, so the probability of A and B will be the probability of A times the probability of B. So let's take a look at some examples. So example 1A says, at a picnic, Julio reaches into an ice-filled cooler containing 8 regular soft drinks and 5 diet soft drinks. He removes a can, then decides he is not really thirsty and puts it back. Find the probability that Julio and the next person to reach into the cooler get. So the key there is put it back. Put it back means that these are independent and they did not change the probability. And we need to know there are 13 total drinks in the cooler. So first we're going to make a tree diagram. So here's Julio. He picks either regular or diet. So he has an 8 out of 13 chance of picking regular, 5 out of 13 chance of picking diet. Decides he's not thirsty, he puts it back. So the next person chooses either regular or diet. And again, since he put it back, it's 8 out of 13 and 5 out of 13. The probabilities did not change. So let's look at Roman numeral 2, the probability of pulling a regular and a regular. So the probability of pulling a regular the first time is 8 out of 13. So that's 8 out of 13 times the probability of pulling a regular again is 8 out of 13. So we multiply these, we get 64 over 169. Divide them out, multiply by 100, I get 37.9%. Number 3, the probability of pulling a diet then a regular. So the probability of pulling diet is 5 out of 13. Regular is 8 out of 13. So I multiply, I get 40 over 169. Which is 23.7%. And finally, the probability of pulling a diet then a diet. So the probability for diet is 5 out of 13, which is 25 over 169, which is 14.8%. Let's look at B. So it says, in a board game, 3 dice are rolled. To determine the number of moves for a player, find the probability of each given situation. So each die has the numbers 1 through 6 on them. And since I am rolling 3 separate dice, there is no chance that one affects the other. So the probability of getting a 6, so there's 6 sides, so that's 1 out of 6. And then a 6 on the next one is 1 out of 6, and a 5 is 1 out of 6. So it's 1 over 216, which is 0.46%. So the probability of getting a 4, that can only happen one way. Another 4, one way, and not 4. So that means it could be a 1, 2, 3, 5, and 6. So there are 5 possibilities for that. So on top, when I multiply straight across, I get 5 out of 216, which is 2.3%. Okay, no threes. Threes only happen once. That means not a 3 happens 5 out of 6 times. And he wants no threes on all dice. Doesn't matter what the number is. So I get 125 over 216, which is 57.9%. Part 4, he wants a 5, a 6, and a 7. So 5 is 1 out of 6. 6 is 1 out of 6. Can you roll a 7 on a dice or a die that's only numbers 1 through 6? No, so that's 0 out of 6. So this has a 0% chance of happening. You cannot roll a 7. 3 5s, so this happens, the only way you can get a 5 is 1 out of 6 times. So that's 1 over 216, which is 0.46%. Any number, so that happens 6 out of 6 times. Any number, again, 6 out of 6 times, not a 2. So that means 1, 3, 4, 5, and 6, which is 5 out of 6. So this is 180 over 216, which is 83.3%. Finally, on 7, rolling a 1, 2, 3, and not a 4. Well, up top, we said we are only rolling 3 dice. So can you get 4 numbers from rolling 3 dice? No. So it's 0%. You're only rolling 3 dice, not 4. So if I look over here, not 3, so that would be 5 out of 6 times. Not 4 is 5 out of 6 times. And then a 1, that only happens 1 out of 6 times. So that's 25 over 216, which is 11.6%. So let's take a look at some of the spinners. So if we look at this first spinner, you can see all 3 colors have an equal probability of happening. There are 3 sections and they're equal size. And we are going to spin 2 times. So the tree diagram, I have 3 possibilities. So I can either spin red, yellow, or blue. Each of them have a 1/3 chance of happening. And then from each of those, I can spin red, yellow, or blue. And they each have a 1/3 chance of happening. So if I want the probability of red, so that's 1/3, and then blue is 1/3. So that gets me 1/9, which is 11.1%. So here I have yellow, so that's 1/3. Not red, so that means it could be yellow or blue, so that's 2/3. So that's 2 out of 9, which is 22.2%. If I look at the second spinner, they are not equally spread out. But what I could do is look at it as these are being divided into 6 pieces. So the purple has a 1/6 chance, the yellow has a 2 out of 6 chance, and the green has a 3 out of 6 chance. So if they're not equally spaced, you need to figure out what the equal spacing would be. So we have purple, yellow, green. So purple is a 1 out of 6, yellow is 2 out of 6, green is 3 out of 6. And yes, I know those can be simplified, but we're not going to worry about it since we're turning it into a percent at the end anyway. So again, on the second round, it's 1 out of 6, 2 out of 6, and 3 out of 6. So the chance of pulling or spinning purple is 1 out of 6. Yellow is 2 out of 6. So that's 2 over 36, which is 5.6%. 3 is green and not purple, so green is 3 out of 6. Not purple is anything but purple, so that's yellow or green, which is 5 out of 6. So it's 15 over 36, which is 41.7%. Okay, let's take a look at dependent events. So the probability of 2 dependent events, if 2 events A and B are dependent, one affects the next, then the probability of both occurring is the probability of A and B, so just like we had up front. So that's the probability of A times the probability of B following A. So that line right here, this stands for B following A. So A, in other words, once I chose A, it changed my percentages. And so now I need to look at B after assuming A really happened. So if I look at example 3A, it says a host of a game show is drawing chips from a bag to determine the prizes for which a contestant will play. Of the 10 chips in the bag, 6 show television, 3 show vacation, 1 shows car. If a host draws the chip at random and does not replace it, then find the probability of each. So the probability of a vacation, that happens 3 out of 10 times. But now he didn't put it back, so now there's only 9 chips left to choose from. So the choice of a car is 1 out of 9. So this is 3 out of 90, which is 3.3%. The probability of pulling a television. So this happens 6 out of 10 times. Now I'm going to assume he pulled a television. So now there's 9 chips in the bag, only 5 of which are television, because the one I chose out, we are assuming said television. So this is 30 over 90, which is 33.3%. C then A. So the probability of getting a car is 1 out of 10 times, well, what's A? There was no A. It was television, vacation, car. So you can't pull an A. There is no A. So that's 0. So this is a 0%. So 3 cards are drawn from a standard deck of cards without replacement. Find each probability. So without replacement. So D stands for diamond, C for club, H for heart, S for spade. Okay? If you are unsure of deck of cards, remember I have that sheet at the beginning of this unit with the decks of cards laid out. So there's 52 decks or cards in a deck. So if I pull a diamond, there are 13 diamonds out of 52. So now there's only 51 cards left in my deck because I pulled a diamond. So club can happen 13 times. But now there's only 50 cards left in my deck. So, and I already pulled one diamond, so there's only 12 left. So this is when I reduce it, it gets me 13 over 850. And you don't have to reduce it because, like I said, you're turning it into a decimal. But if you're using a fraction bar to do the multiplying, it will automatically reduce it for you. So the chance of pulling a heart happens 13 out of 52. But I pulled a heart, so out of the 51 cards left, the chance of pulling another heart now goes down to 12. Okay, I've pulled 2 cards, so I only have 50 cards left in the deck. I've pulled 2 hearts, so it's 11 out of 50. So this gets me 11 over 850, which is 1.3%. So let's take a look at example 4. We need to first decide if it's independent or dependent, and then we can do the probabilities. So looking at these first 3, it says Yana has 7 blue pens, 3 black, 2 red pens in his desk drawer. He selects 3 pens at random with no replacement. So no replacement already means this is dependent. That means my bottom number is going to change as I go. What is the probability that he will first select blue? So when we write this out, probability of blue, then black, and then red. So when you're writing it out, always write down what is the probability you're looking for. So they have 12, or he has 12 total pens. So 12 total pens. So the probability of getting a blue pen is 7 out of 12. Now he only has 11 pens. Probability of getting black is 3. And he only has 10 pens left in the drawer. Probability of getting red is 2. So this is 42 over 1320, which is 3.2%. B, a black die and a white die are rolled. So those are 2 separate dice. So that is independent. So what is the probability of a 3 on the black and a 5 on the white? So the probability of a black 3 and a white 5, and you can write it out in words or you can shorthand it, doesn't matter. So the probability of getting a 3 on the black dice is 1 out of 6. A 5 on the white dice, that's 1 out of 6. So that's 1 out of 36. So that is 2.8%. C, Tammy, Sonia, Michael, and Roger are 4 candidates for student council president. If their names are placed in random order on the ballot, what is the probability that Michael's name will be first on the ballot, followed by Sonia's name? So those are dependent. They depend on one another. So the probability of Michael, then Sonia. So what's the probability of Michael being first? 1 out of 4. But now there's only 3 people to choose from. So the probability of Sonia being second is 1/3. So that's 1/12, which is 8.3%. Let's take a look at the last two. Joe's wallet contains 3 $1 bills, 4 $5 bills, 2 $10 bills. If he selects 3 bills in succession, so that means he's not putting them back, find the probability of selecting a 10, a 5, then a 1 if they're not replaced. So those are dependent. So the probability of pulling $10, then $5, then $1. So to begin with, he has 9 bills in his wallet, 2 of which are $10. Now he only has 8 bills left, 4 of which are $5. Now he only has 7 bills left, 3 of which are $1. So you get 24 over 504, which is 4.8%. And the last one, it says a bag contains 6 green marbles and 8 yellow marbles. Carlos randomly selects one, then puts it back and selects another. So this is going to be independent. What is the probability that he will select green, 1 green, and then 1 yellow? So there are 14 marbles in the bag. The probability of pulling a green is 6. The probability of pulling a yellow is 8. So I get 48 over 196, which is 24.5%. Again, if you have any questions on this, feel free to ask. Thank you. See you tomorrow.